We all know how bad you can feel after a poor night of sleep, but research shows that the cumulative effect of night after night of short or disturbed sleeping is more than irritating, it has health consequences. My guest today, Dr. Minjee Kim, studies the role of sleep disturbance and cognitive impairment, Alzheimer's disease, and related dementia, and aims to design healthcare interventions for the early detection and treatment of sleep disturbances that could lead to longer, healthier lives for all of us. Dr. Kim is a Northwestern medicine neurologist and an associate professor of neurology in the Division of Neurocritical Care at Feinberg. The research in her lab is driven by the belief that quality sleep is a fundamental human right and that its preservation is essential for healthy aging. We welcome her to the show today to talk about her research and innovative ways she's trying to bring a better night of sleep to those who need it. Welcome to the show, Dr. Kim.
Thank you for having me. Such a pleasure.
Let's start with the basics. More than half of adults do not get sufficient sleep. What constitutes as sufficient sleep? And what are some of the top reasons why so many adults are not getting enough?
We still don't know exactly how many hours of sleep is sufficient for an individual. Studies of lots of people, these epidemiologic studies, have characterized sort of how many hours people generally sleep in different life stages. How short of a sleep is bad for various health outcomes. And the societies have come with a guideline to say 6 to 8 hours of sleep is probably what most people need in midlife and into the older age. That being said, certain people who I call the lucky people don't need to sleep that much and they can function just fine. And we found some genetic polymorphism associated with that. So it's not universal that you need exact number of hours of sleep per night to carry out a healthy life. But I would say generally 6 to 8 hours are probably a good number for most people.
So it's not just hours that are important too, but the quality of your sleep.
Absolutely. Yes. So people have focused on sleep duration for many years, and a lot of research have come about the short sleep or longer sleep duration and what is good and what is bad. But now people are recognizing that sleep is not just about the duration. The construct of this multidimensional sleep health is rising to really recognize the various aspects that constitute sleep, right? So, good sleep, what would you think a good sleep should be,
Oh, like you don't wake up several times in the night.
right?
You feel rested when you wake up.
Yes, yes. So, sleep should function to maintain an adequate daytime alertness, right? You should feel good when you wake up, should be refreshing, and it should be restorative. All of that should be enough time, also should be consolidative, that you should not wake up too many times at night. The other thing that we often forget is it should be regular from day to day. You should probably go to sleep around the same time and wake up around the same time. So, there's a weekend catch up sleep you can sleep in. It's probably not a good sleep health. So now we're thinking about these various aspects: alertness, regularity, satisfaction, duration, and timing to define a good sleep health.
Tell me a little bit about your background as a neurologist and what led you into sleep and now doing these studies on these different age groups and different folks.
We spend about a third of our lives sleeping, and sleep isn't unique to humans. Virtually all animals have some form of a sleep wake cycle, even though being asleep can make them vulnerable to predators and other natural risks. That's always intrigued me. Like, why would such a risky behavior be so universal across species? The sleep must serve a fundamental role in our biology. And we now know that critical processes occur during sleep, including memory consolidation, clearance of metabolites that can be toxic to brain cells. So, sleep isn't just passive rest, it's an active work that's essential for healthy brain and bodily function. I work in the neurological intensive care unit, caring for patients with severe brain injuries or those experiencing brain dysfunction due to failure of other organs like the heart, the liver, the kidneys. And in this setting, even the definition of sleep becomes murky. Some of my critically ill patients are in a coma. They're not awake, but they're also not sleeping in the traditional sense. There are no characteristic brain waveforms, and we can't wake them up. The injured brain appears to lose its ability to maintain a normal sleep wake cycle or even generate the state of sleep at all. So we don't yet fully understand whether this breakdown in sleep is just a byproduct of illness or whether it's part of brain's adaptive response, maybe even a protective mechanism. Interestingly, patients in a coma who do show sleep-like activity, brain activity, often have a better chance of recovery. That suggests that sleep or the ability to generate sleep may be important, not just for daily functioning, but also for healing and resilience. But zooming out to a broader view outside of my clinical work, I think we are facing increasing challenges to maintaining good sleep in modern society. It's probably much harder to consistently sleep 7 to 8 hours a night in April 2025 than in 1825 when people used candles to get around and didn't have the constant distraction of emails and streaming content. So I think in modern society, many aspects of the life degrade the quality of our sleep across the lifespan without us actually realizing the harm. And I believe that cumulative toll impacts our long-term health. So that's how my research is driven now to find ways to improve sleep health in everyday life to promote overall well-being and healthy aging, cognitive aging, and aging in general.
Oh, that's fascinating. And you mentioned light and you mentioned candlelight versus the glow of a smartphone. This is something that you've studied in several different populations. Tell me about this work. One study you looked at pregnant women, and this was published in the American Journal of Obstetrics and Gynecology, Maternal Fetal Health. Another study was published in the journal Sleep, where you looked at light exposure on middle aged folks. Light exposure, there is some impact here on these populations. Can you tell me about that?
I'm following really the footsteps of giants in the field who made major discoveries about the circadian clock and how the circadian clock is important and what is happening in modern society that's really affecting the natural circadian rhythm in our body. So just to go back, the circadian clock, it exists in all cells of our body and not just humans, but all animals. So there is a natural light dark cycle that's driven by the sun and the moon to some degree. And we've all evolved to function optimally in that natural setting. With this artificial light and other stimulus, we are getting less of that natural signal that drive and synchronize our circadian clocks in the body. So the beliefs are that we are not getting enough signal and there are other random non-natural signals that are affecting our circadian clock. So it's getting desynchronized and they are not optimal to maintain the body's functional homeostasis. So that drove some of my research into the light exposure and metabolic dysfunction in people. It is really hard to disentangle the light dark cycle, the circadian rhythms, and the sleep wake cycle because they are somewhat associated, right? Then people always thought, okay, the light before sleep is going to affect your sleep, and that's why it's bad for your health. And we actually also assumed that, but some of this research we've done seem to suggest otherwise. So go back to the light exposure in older adults. This was a cross-sectional study who were recruited a long time ago in their 20s. And they were followed many decades later, now in older age, and looked at what kind of chronic disease they have developed and the sleep patterns that they now had. The caveat of that was we didn't know how they slept before. And here we looked at the light exposure during the sleep period and older adults who had any light actually during their sleep period were much more likely to have conditions like diabetes, high blood pressure, and we can't infer any causal relationship there. And it could be that people with those conditions tend to wake up more and they turn on the light. But that was a one study that started this journey into the light and health research.
Hey, listeners, if you're enjoying this episode, please share it with a friend and follow us on Apple Podcasts or wherever you listen to podcasts. Now back to the episode.
Then, thanks to all the collaborators at Northwestern, I had access to this amazing data set of pregnant women who were recruited between 2010 and 2013 during their first pregnancy. And here we looked at their sleep patterns and how they were exposed to light. Just like in the older adult, I was initially interested in the light exposure during sleep and how that's bad for them. One major metabolic dysfunction that occurs during pregnancy is gestational diabetes. So your insulin resistance is impaired, and that can lead to many adverse outcomes lifelong. So it seemed natural to look at sleep pattern and light exposure in early pregnancy and the risk of gestational diabetes, which happens in a second trimester. But luckily for these participants, a lot of these people had no light exposure during sleep. So it's like, oh, that's good. But then what happens during the day, right? Like, how much of light should we get at what time of the day? And we still don't know the answer to that. But if we emulate what happens in the nature, then we should probably get a lot of light during the daytime, especially early hours, and less after sunset. So that's how we thought about, okay, then let's look at the hours just before bedtime, because in 1825, there's no light, right? It took a lot of effort to get any light. But now it takes a lot of effort to turn off the light. So if you get a lot of light before sleep, is it going to affect your sleep for one? And two, your risk of gestational diabetes. So then we didn't know how many hours is enough. So we looked at 1 hour, 2 hour, 3 hour before each night bedtime. And it actually seemed to give pretty consistent message. So we picked 3 hour, which seemed reasonable based on the guideline of defining the evening hours. And women who were exposed to most light in this period, regardless of the light exposure the rest of the day, seem to have an increased risk of developing gestational diabetes, even after adjusting for potential confounders. But these women actually slept better. So that was very strange. And I remember just looking at the data, like, am I making mistake? Are we doing this right? So they were sleeping well. So there was this discordance between the metabolic risk and then the traditional belief that the effect of light exposure is through the effect on sleep. So it wasn't the case. So it seems to have an independent adverse effect on the metabolic regulation, at least in this time period.
And it's important to note you're capturing this light exposure through kind of like a fancy Fitbit or Apple Watch. Is that right? That they wear?
That's right. So if we could choose, we would put a light sensor right here next to our eyes because that's how our brain sees the light. And that's how our circadian clocks perceive the light. But we still don't have a device that's convenient enough to do that. So we capture light at the wrist level, ask our participants to wear this, like, let's say, fancy version of Fitbit for anywhere between 7 to 14, sometimes longer days, and capture the light exposure throughout those periods.
So that's interesting. It kind of opens up this whole new world of not only do you have to worry about your duration and quality of sleep, but then your light exposure during the day and before bed. So lots to explore there. What practical steps can people take to reduce their risk of light exposure at night?
I would say just be mindful, first of all, of what lights are around you. And I'm actually going to share this constant kind of battle with my husband. I have two young children, they're 3 and 7. There's more research coming out demonstrating how sensitive children are to this evening light. So, to adults, we generally say dim light, less than 5 to 10 lux is probably okay. Recent research suggests that children, even at a very dim light, their melatonin goes down. It's not good. So then it's very hard to turn up all the light because night light, we have stairs, and the safety. So we try to dim most light and then turn up screen for one. I actually have glasses that block blue light. The evidence is, it's coming up. We'll see. It's jury's still out there, but at least that's something that I am doing that I think people can easily adopt. It's not as easy to reduce the light level at home, but you can turn up the devices and, turn up the blue light mode and then use warmer light, night light if you have to. Just dim everything and be mindful of it. And, those glasses are inexpensive and it probably wouldn't hurt. I don't know if there are benefits yet, but the jury's out there hopefully will have more evidence on that.
So there's been two studies recently you've done with either pregnant or postpartum women looking at metabolic health. Tell me about that population and why it is that you were so interested in studying them.
Generally, in the field, a lot of studies have been done looking at the link between sleep and cognitive function and aging. What people are realizing now is that it might be chicken and egg situation. Poor sleep likely leads to poor brain function, but the poor brain also cannot generate good sleep. So then, are you actually looking at the byproduct of the brain changes and calling it as a risk factor? Because these changes happen at the same time. So then can we do something about it if it's actually injured brain unable to generate good sleep? So the field is moving to an earlier life stage, midlife. And for women specifically, the challenges are unique to them, including pregnancy and menopause, right? We know that short sleep duration is linked to many adverse health outcomes, cardiovascular disease, cognitive decline, even mortality. And this relationship seems to vary by age and sex, men and women separately, and also across the life stages. So that's how I was interested in this cohort study that followed the pregnant women who were pregnant between 2010 and 2013. It's ongoing now, 10-year follow-up. Now they're entering middle age. And they have been characterized for all kinds of biological and psychosocial changes. So then can we look at some of the changes that happen in there early or just before the midlife? And there must be something that can be intervenable. The previous research have focused on pregnancy and menopause, but there have been gap between those two life events. The parenting years, it's hard to maintain good sleep. There's so many challenges. And I may even say that sometimes harder than the pregnancy itself. And the people also have multiple pregnancies.
The middle of the night feedings and bad dreams and getting up to tend to children that can be very disruptive.
Very disruptive, right? So that the research that have been done in the immediate postpartum period, 6 months, 1 year, and even up to 2 years, and how women's sleep, even feeding schedule can affect overall well-being. But then the study really drops out. We don't know what happens after that when most children would sleep through the night. But still, there are challenges. So that's what we were interested in. Like, what happens in these early parenting years? And if people either develop a new inadequate sleep or continue to have inadequate sleep, then would that affect their long term metabolic risk? So we leveraged the data set of pregnant women who were enrolled during their first pregnancy and followed 2 to 7 years after the index delivery. And about 4,000 women reported both sleep duration during the pregnancy and again a follow-up that was about 3.1 years of interval. The median sleep duration decreased from 8 hours to 7 hours. So people are sleeping less. About a quarter of them had less than 7 hours of sleep during pregnancy, which then rose to 35% at follow-up. But there was significant shift. Some people now have new short sleep and some people have resolved short sleep. So there are changes. And what we found was that about 13% of the participants developed a metabolic syndrome at follow-up, which is a constellation of conditions like high blood pressure, dyslipidemia, obesity, and insulin resistance. And this is thought to be a significant risk factor for cardiovascular morbidity and mortality later. And people who had a persistent short sleep, meaning slept less than 7 hours both during pregnancy and at follow-up, were at significantly higher risk of developing this metabolic syndrome just over little over 3 years of follow-up. And when we define the short sleep as less than 6 hours, so it's more severe short sleep, the risk seemed even greater. Now, having short sleep at either time point or both time points were all associated with the greater risk. So there might be a dose-dependent relationship between short sleep and metabolic risk. I think this is important to know because metabolic syndrome is considered a modifiable risk factor. So this might be the time to intervene before these women go on to develop a full-blown cardiovascular disease. Also interesting is that other longitudinal studies have shown that sleep duration is relatively static across midlife. So people who sleep little continue to sleep little for 20 years from age 40s and on. But we saw a lot of shift in sleep duration. So this is a time that people are vulnerable to establishing suboptimal sleep habits, and maybe we should do something about it. And the other thing is that the burden of inadequate sleep duration was not uniform across racial and ethnic groups. The non-Hispanic Black mothers were much more likely, almost twice as likely to develop unusual sleep and more than twice as likely to continue to have short sleep at follow-up. We don't know what's driving this. There are probably multiple factors, including structural racism and other things that we can address in different ways. So this is going likely to expand and widen the health disparity over the lifespan. So I think the next step for the field is really to think about developing an intervention in this life stage that's culturally appropriate, that can modify the long-term cardiovascular and also that leads to neurologic risk over time.
What do you think that could look like?
Even something simple like awareness and counseling of sleep habits. Turn off the light and try to maintain consistent time for bed. So if you think about I need to go to bed at 9 o'clock to maintain 7 hours of sleep, then start turning off the light at 7 and then winding down at 8 so that you are more likely to fall asleep at 9. So just be mindful of that. Not like you're constantly doing something up until 9 o'clock and I gotta go to bed. It's much harder to turn that off.
So you're currently working with other Northwestern investigators on the MidCog study. Explain this study to me and how it contributes to your research on sleep and cognitive function.
Yes. So my mentor and collaborator, Dr. Michael Wolf, is a phenomenal researcher, and he has carried out a longitudinal cohort study of older adults over almost 2 decades. We've learned a lot about what happens in older age, but now we're realizing that a lot of risk factors actually start developing in earlier life stage in midlife, as we talked about earlier. So this is his new cohort study that is looking at potentially modifiable risk factors of cognitive aging in this lifespan. When I start talking to him back in 2021, we clicked because I've always been interested in sleep, but not in this general population. And he's carried out successfully these cohort studies for many years, but he has not investigated sleep. So I say, let's collaborate on this. Let's add a sleep aspect to this. I think this is a major gap. So this cohort study recruits about 1,200 people from the greater Chicagoland area from primary care. And we are characterizing potentially modifiable risk factors, including physical activity, diet, and chronic conditions, vital signs, plus sleep and rest patterns. We are asking them to report their sleep quality using multiple validated questionnaires. And we're also asking them to wear this fancy version of Fitbit to characterize rest activity patterns. What we are trying to achieve with this cohort is to better understand what happens in midlife. Like, how do people sleep? There are major gaps in that knowledge. And what aspect of sleep is particularly bad for your health, not just now, but also in a lot later life stage, that we can do something about it.
Well, and you're leveraging AI and the electronic health records as well to develop tools to maybe detect people who have sleep issues but aren't being treated for the problem. First, tell me about this problem of sleep issues being overlooked in primary care and how you plan to tackle this problem with AI and electronic health records.
Yes, actually, this is completely new area that I am delving into. Many years that I've used and leveraged these cohort studies, I was always a little bit flustered by the fact that there are all these observational studies suggesting that poor sleep is bad for you. There have been relative paucity of intervention studies showing that what we can do about it. And I think one of the major roadblocks there is that it's hard to find these people with poor sleep, no matter how you define it, because it's not on your chart and people don't advertise it. So even though 1/3 of people sleep not enough, you have to put in significant effort to identify those people and screen them, make sure that they're eligible for studies. It's very labor intensive. And once you find an intervention that works in this group of people, how can you implement it? And all these people, you again have to find them As I was sort of struggling with this gap between the knowledge that we're accumulating and what we can do about it, now there is this major advances in artificial intelligence and also widespread use of electronic health records. And this seems to be really an optimal combination that can change and tackle these roadblocks that we've had. What we are trying to do is utilizing this functionality. So let's say this MidCog study is recruited through primary care. And because of that, we actually have access to the participant electronic health records. So what we are trying to do is, okay, so we identify these people with sleep problems of different types. Can we now predict who's going to have these problems without asking them to wear all this fancy watch and answer questions and questionnaires using artificial intelligence? Then if we do that, then can we nudge the clinicians when the patients come to see them for annual visit or anything else? You are at risk of sleep problem that's bad for you. And it might trigger a simple question. And if it seems to be the case, then okay, then there's something that we can send you to. We can refer you, or we can provide some sleep hygiene things that they can do something about. We don't know whether that's going to work, but at least that's the idea of the next steps.
Okay, so this is really new. As you mentioned, you're doing a pilot of this. What can you tell me about that?
So the pilot study that we just completed was trying to find sleep apnea in older adults in primary care and send them to diagnostic studies, then treatment. It was a minimal effort for the clinicians or the patient. We send a screener, that's a 4-item questionnaire, to patients who are 65 and above who come for wellness visit. And if they answer those questions in a way that they seem to be at risk of sleep apnea, then the clinicians are automatically nudged to ask them about sleep habits and order diagnostic study. Then what we wanted to know in this pilot study was, is this going to work? Like, do people find this burdensome, or do people actually follow through with the recommendation? We were actually surprised that these older adults, over 40% of them actually did complete the screener, and a significant number of them followed through with the recommendations and were diagnosed and started treatment for that. So minimal effort, it was not costly, but made some differences in people. So that was the pilot study that we're going to also utilize for the next step in different settings and also in middle-aged adults.
You've been really busy. You've been putting out a lot of studies. You're working on these pilot projects. You're working with all these investigators. What do you hope happens with your lab and your work in the next 5 to 10 years?
I have a lot of ideas, but what I would like to focus on is this pilot study of utilizing AI and electronic health record functionalities to intervene or detect bad sleep patterns or suboptimal sleep patterns and intervene on it. I think that's where I would really like to focus my efforts on, because that's scalable, that can be modified in different settings. And that's my dream and the goal. Like, can we all sleep better? That's a fundamental human right that we don't know about. And then, but I think we should all sleep like it was 1825.
I love it. Well, sleep like it's 1825. That's great. Thank you so much for all this insight and sharing the incredible work that you're doing. I really appreciate it.
Thank you.
Thanks for listening. Please click the bell to receive notifications about our latest episodes and follow us on social media at NU Feinberg Med to stay up to date with our latest research findings.